Hello, today we'll understand how to apply the Hess's law to solve a complex problem where we have to find the enthalpy change for a given reaction. So let us take up the question and understand the process and see how we can make it easier for ourselves. Here the question says that acetylene is formed when calcium carbide is reacted with water, for which we've been given the equation, but we haven't been provided with the value of delta H, and which we are supposed to be calculating. But we can calculate this using these 5 different chemical reactions whose enthalpy values are given to us. Now, what we first need to do is look into our target equation. The first reactant is carbon. Carbon is present in 2 different equations, one over here in equation number 1 and the other one over here in equation number 4. So let us leave out that carbon and move to the next one. Hydrogen is the next reactant. We have it only in one of the reactions, so we can deal with it. We need it on the reactant side. This is on the product side, so which means we need to flip this equation, and at the same time we need 1 mole of it. We have been given 2 moles of it, so we have to also divide this by a 2. Keep in mind, whatever you're doing with the reaction, you're doing the same thing with the enthalpy change also. So when you're flipping the equation, changing the reactants into products and products into reactants, you're flipping the sign of the delta H. So if it is positive, it becomes negative, and if it is negative, it becomes positive. And if you're dividing the equation by a 2, you're dividing the value of enthalpy also by a 2. Now let us go to the next product, so which is like acetylene, and this is present only over here in one equation. We need it on the product side. We have it on the product side. We need 1 mole. We have been given 1 mole, so we really do not need to do anything with equation number 5. We're just going to keep it as such. So we are going to use equation number C and equation number E. So for C, we are changing reactants into products, products into reactants, and at the same time dividing the balancing coefficients by a 2. So we get half O2 plus H2, which is a gas. It gives us H2O, which is a gas, and the delta H value negative 286 kilojoules. Now equation number 5, we're just going to copy it down as such. We have calcium carbide, which is a solid, plus 2H2O, which is a liquid. It gives us calcium hydroxide, which is a solid, and C2H2 acetylene, which is a gas. And because we haven't done anything, the delta H value remains the same, negative 126 kilojoules. Now let us first add these 2 equations, and then we'll figure out what to do next. So here we can see that we have 2 water molecules on the left and 1 water molecule on the right. So we can cancel out 1 water molecule and we'll be left with 1 water molecule on the left. So let us now add them. So all the reactants, we'll write it on the left, and all the products, we'll add them and write it on the right. So now we have CaC2, which is a solid, plus half O2, which is a gas, plus H2, which is a gas, plus H2O, which is liquid, and this gives us calcium hydroxide, a solid, and C2H2, a gas. Now when we add these 2 values of delta H, where you get the value of delta H over here as negative 412 kilojoules. Now the next thing we have to see is that we do not want this calcium carbide in our target equation. So to get rid of it, we know because this calcium carbide is present in reaction number D. To get rid of it, we need calcium carbide on the right. We have it on the right, but we need only 1 mole. So to change it into 1 mole, we need to divide this equation by 2. Let us put it down after dividing it by 2. So we have calcium oxide, which is solid, plus 5/2 carbon, which is graphite, and that gives us calcium carbide, which is solid, plus half CO2, which is a gas. And now delta H for this, we need to divide this value by 2, so we get 376.5 kilojoules. Now let us again add these two reactions. Now we are easily first able to cancel out the calcium carbide on the left and on the right. Nothing else is getting cancelled out, so let us write our sum of the above two equations. I'm going to write it over here because it's going to take a little bit of more space. So we have calcium oxide, which is solid, plus half O2, a gas, plus H2, a gas, plus H2O, liquid, plus 5/2 carbon, which is graphite, and this gives us calcium hydroxide, a solid, plus C2H2, which is a gas, plus half CO2, which is again a gas. Now to get the value of delta H, because we have added the equations, we'll add their enthalpies. So on adding negative 412 and 376.5, we get negative 35.5 kilojoules. Again, if we look into our equation, what we've got, the first reactant, we again don't need it in our target equation. So now we can use this equation number B. We need to have this calcium oxide on the right to get it cancelled. So what we are going to do is we'll just flip equation number B. So flipping it, it gives us calcium hydroxide, gives us calcium oxide, both of them being solid, and then plus H2O, which is a liquid. Because we flip the equation, so the delta H instead of negative turns out to be positive, which is 65.3 kilojoules. Let us add these two equations again. We can see that calcium oxide on the left and on the right gets cancelled. Calcium hydroxide on the left and the right gets cancelled. And water on the left and the right gets cancelled. So our resultant equation is half O2, which is a gas, plus H2, which is a gas, plus 5/2 carbon, graphite, gives us C2H2, a gas, plus half CO2, gas. So now we have to add these two values of delta H. So delta H is going to be negative 35.5 kilojoules plus 65.3, which gives us 29.8 kilojoules. So we have actually dealt with all these four equations. We are only left with equation number 1. So again, if we compare what we have with our target equation, we know that we don't need the oxygen. So to get rid of it, we can use equation number 1, but we need to have this oxygen, half a mole of it on the right side. We have it here on the left. So equation number 1 needs to be flipped and at the same time divided by 2. Let us put it down. So we have half CO2, which is gas. It gives us half carbon, which is graphite, plus half O2, which is again a gas, and then delta H will be flip the sign, so 393.5 and then that divided by a 2. It gives us 196.75. Now let us add these equations again. So now our oxygen on the left and the right gets cancelled, carbon dioxide on the left and the right gets cancelled, and now we have 5/2 carbons on the left and 0.5 carbons on the right. So which means 5/2 minus half, which is 4/2, and 4/2 is just 2. So we have 2 carbons, which are graphite, and then plus hydrogen, which is gas, and it just gives us acetylene. And for finding the delta H, we are just going to add these two numbers. On adding these two numbers, we get delta H as 226.55 kilojoules. So we can see that this is our target equation. We have our target equation the same way written down over here. We did not have the value of delta H, but we have it now, the delta H value as 226.55 kilojoules. I hope you understood the process. See you in the next one. Bye-bye.